There are two more special cases whose derivatives we need to be able to take. And the first would be if you have the derivative of a natural log. So for example, let's say that f of x equals the natural log of the cosine of x. Now there are two issues here. One is this is going to involve the chain rule, and two, we need to know what the derivative of the natural log is. In general, the derivative of the natural log of anything is equal to 1 over the argument, which is what u is called, times the derivative of the argument. So in this case, f prime of x is equal to 1 over the argument, or 1 over cosine of x, times the derivative of cosine x, which is negative sine x. And if we simplify this a bit, we end up with negative tangent of x. Alright, so the key for natural log is recalling that the derivative of anything natural log is the 1 over the argument times the derivative of the argument. And we could also have things that don't involve the natural log, right? Just logarithms in general. And so an example of this might be what a function like log base 2 of 2x. And this is still going to involve the chain rule and also just knowing the form. In general, the derivative of the log of any base with any argument is always going to be equal to, just like natural log, 1 over the argument. But it's also times the natural log of the base in the denominator, and then that is being multiplied by the derivative of the argument. So in our example, the derivative, or f prime of x, of log base 2 of 2x is equal to 1 over the argument, so in this case 1 over 2x, times the natural log of the base, in this case 2, times the derivative of the argument, which in this case is 2. We could simplify this a bit and end up with 1 over x times the natural log of 2. So again, it's a combination for these of knowing the form and recalling the chain rule.